All right, so like I said, we are starting chapter 2, part 2, just a continuation of chapter 2, part 1. So we're still doing math. And we're gonna just not do too much today. We're gonna start right off the bat with just some vocab words. So the title of page 24 is mapping fields. So we're gonna be making maps of a field. And what comes to your head when you hear field? Cornfield, baseball field, football field, that right there out, it's a small field, but that's a field right there. That's not exactly what I'm talking about, but that's not what I'm talking about. So here's the official science definition of a field. It's a generic, do you guys know what generic means? Yeah, like a general term. Like you could have, tissues, you guys know tissue and that you blow your nose into? And you could have a name brand, Kleenex, Puffs, or in general, we can call them all tissues. So it's generic would be tissues. So in this case, it's anything that's being measured. So yes, we could map that field. We could measure the football field or the baseball field or the cornfield. But it's really just any term for whatever it is we're looking at. So the field could be this classroom, or this hallway, or the whole school, or the whole district of Pioneer, that from one edge of the district to the other, or it could be all of New York State. All of those things could be a field. So it's whatever you decide to make a map or take a picture of. Everybody good with field? Did you write this in your notes? So this was a problem last period. Here's the notes. They go in your notes in your packet. It looks like a couple of you forgot to do that too. So not sure what it is about today that's causing a problem with taking notes.
Friday.
It is Friday. And guys, is Monday off?
And taking notes before.
Well, it is, but it is nice to have somewhere to flip back to. I know you don't like doing it, but I know it does help every once in a while. Maybe not all the time. My daughter's earth science teacher, I know I keep talking about her a lot, but her earth science teacher, they don't take notes. And she's like, I don't know what a field is. I'm like, well, look back in your notes. She's like, what notes? So they don't do notes. I don't know how they do it, but she's not taking notes. All right, ready? The next word is isoline. Let's take that word apart before we write the definition. What do you hear in there?
ISO.
Iso and
Line.
lines. You guys know what a line is? I actually don't know how to teach you what a line is, but you know what a line is. So no, we're not even just talking about latitude, longitude. It's just whatever line you draw. Like there's a line. Like that's all I'm talking about. Nothing fancy. Well, let's talk about the word iso. Like isolation, if you're in an isolation room, like back when COVID was a big huge thing, you had to isolate. Now, if you and your entire family had COVID, you isolated together. But technically, if only you had COVID and the rest of your family was healthy, what were you supposed to do?
Isolation.
All by yourself. So all the people that had the same illness could be together. But if you had different illnesses or didn't have it, you had to be separated. So that's one example. How about in math class? Do any words start with iso in math class? They do. What is it? Isosceles. Oh, okay, rack your brain. What the heck is an isosceles triangle? And what was that last second part? Not only that's an isosceles.
That's not twos.
That's not juice. I'm just taking his word for it. I don't think it's an isosceles. Isosceles is, like Keith said, I think that was you, right? Or was that? Okay. So Keith said they are when two sides are the same. And that's what we're gonna be working with. Same. Iso basically means same. Has anybody done isometrics if you're working out? No. That's when you would work one set, like the same body part over and over, like during that workout session, like you do your back or you do just your quads. You don't mix in quads and back and shoulders in the same workout. So iso means same. So same lines. An isoline is a line that connects points of equal value in a field. So anything that's the same, an isoline will connect them. Again, this is like a generic term. Any line that connects equal values is an isoline. Thanks. So I can find it, and that's probably my favorite color. I like it because it's right. I like to stand out. I like to be different. I like to be able to put that in my purse and find it without thinking. So there's lots of different kinds of isolines. Anything that connects equal things. Can you think of anything equal on a map that we might want to connect, that we could put on a map that we might want to connect up? What do you mean by Earth? Okay, so that's not a value. So can you think of any values? So things we might measure that might be helpful to show where all the equal ones are on a map. What about the ocean? Okay, ocean current depth is probably the better one. So we would show where all the equal depths are. Because you might want to know when you're going fishing, for example, you might want to know where a nice deep spot in the water is, because that's where all the big fish might be hiding. Or I actually know nothing about fishing, so maybe not that, but what's some other equal things that you might want to have on a map so you can just see on a map what's going on pretty easily? Nothing, because you guys don't ever read maps, right? No, that's what I thought. All right, so one thing might be temperature. These are called, and this is the next vocab word, isotherms. So again, we got same, and what does therm mean to you when you hear therm? Thermometer or thermostat, which all control or deal with temperature. So isotherms are lines that connect areas of equal temperature. If you have ever watched a weather report on the news, you have seen this map. You know, when they color code it, like all the places that are 90 are red, all the places that are 30 might be blue. Yeah. Absolutely. We're going to get to that one in a second. It's called a contour line. If you've ever gone hiking or off-roading, you might want to see where the hills are, where the valleys are, what kind of hike you're going to be taking. Is it steep? Is it gentle? Skiing, absolutely. You want to be able to see where the mountain is the steepest. That is another one we're going to do, and that's what that's basically the whole packet, is connecting areas of equal elevation. Another one, so we're going to use isotherms. We're going to learn how to use them this chapter, but they're going to come into play big time when we get to weather in like March-ish. So isotherms are a big one, and the next one, everybody ready for the next one? Isobars, so not areas of equal drinking establishments, but isobars are areas that connect equal barometric, which is a fancy name for air pressure. And again, we're going to learn how to make these, draw them, read them this chapter. But again, we're not going to use them big time until we get to March. I missed it, Cole. Another one, you don't have to write anything here. I didn't put notes for this one, but another thing you could make a map of is concentration of chemicals. And I like to use that dog food plant in Arcade as a perfect example of that. So if we had the dog food plant, right here. If we, yeah, maybe I shouldn't have gone this far yet. So if we had the plant right there, what do you guys know about how strong the smell is when you're close to it? Okay, it's really, really strong when you're close to it. What happens when you go further away? Can't smell it, or at least, so you might have a line that goes around the dog food plant, that if you live on that line or within that line, it's like very strong. But then what happens if you like lived here? It's gonna be less strong. So we're gonna draw a line around that. And then I think you get the idea. If I keep going, they're both like there's somewhere over here and somewhere over here that's even less strong. And you can make a map. Now, would it always be a perfectly circle map around the dog food plant? What do you guys know changes the smell? Wind direction and heat, absolutely. So if the wind was blowing this way, these people over here might not ever smell it. So it might be like only if you're practically right on top of it do you smell it. But then the smell might go really far in the other direction. Same with heat. If the wind's not blowing, it's really hot, it probably is excruciating right next to the plant, but maybe nobody else notices it. So this is what you can literally make a map like this about anything. One that they do all the time is if like there's an oil spill. Back when I'm guessing you guys were probably babies, there was an oil spill in the Gulf of Mexico, and they would show it on the news every single chance they got. They would show a map like this showing where the highest concentration of oil was and then how far and where it was spreading. And you could match it to the waves and the ocean current. I don't know off the top of my head, but now that I'm thinking about it, I think it might have even been before my daughters were born. So, and if it wasn't, they were just babies. So you guys are probably too little to remember.
No.
No, you do remember it, or no, you don't remember it? You're just saying no. Okay. But basically we can make a map for legit anything you can measure, we could make a map of. So I always say, we're getting close to Halloween. We could survey everybody in the town of Delavan and ask them how many pumpkins they bought to decorate. And then we could make a map of who buys the most pumpkins. And you might be able to then like make a connection with like this street gets really into it and that street could care less. So you can make a map of anything you can count, you can measure, or you can map. So speaking of a map, oh, the Weather Channel loves these guys. Here's a version that you might have ever sometimes seen, but probably not one like this. This one's more like geared towards scientists because it kind of looks overwhelming to you guys, right? It doesn't look overwhelming. Do you get anything from a map that looks like that? Do you, as not a scientist, get much from that?
No.
Not really. But what if I color coded the map? Could you at least read it pretty quickly? If you're in the red area, what's that mean? Okay, it actually means you're gonna need high heating needs. If you're in the blue area, you're gonna need high cooling needs. The green area, what do you think? Medium, it means probably they can just open their windows and be comfortable. But this map that was super like overwhelming and you didn't get much from it, we could color code that. So this line right here is 1004, this one's 1006. So if we shaded in the area between them, one color, and then took another color for a different section, it would probably be easier for you to read. Same idea, it's just going to be color coded. And I know you're not getting much from what I just did there either. But I'm just showing you that this map is basically just a non-color coded version of the next one. But like I said, you can make them out of about anything you can measure. Take a look at the title of this map. Aches and pains. They must have measured aches and pains, maybe sent out a survey, maybe asked the doctors in the area to collect some data for them. And then they put it on a map. And you can notice some trends. What was the first thing you noticed?
New York and Python.
Yeah, New York and this whole East Coast over here, we're at the high end of pain. But then we got Florida that has like no pains. has baffled me every year I've looked at this map. Who lives in Florida? Okay, well, I can't comment on that, but in general, if you think of old, Florida, what's the first thing?
Old people.
Oh, I think of old people.
Retired people.
Old retired people, snowbirds maybe. And then I think, well, don't old people complain about aches and pains a lot? I know my parents do. But then maybe when you move to Florida, you don't complain about it. Maybe only when you're in New York, you complain about it. I don't know.
Because it doesn't get all cold. Really
Right, so it's not cold and you don't complain, like, and they're just so happy they're not in the cold, they're not complaining.
Or they're retired.
Yeah, or they're retired and right, can't complain if you're retired, you got nothing else to do. I don't know, but it's easy to see on this map, once you color code it. My favorite is over in, California. They don't have any. Like, what's going on in California that they're
How
not,
do they have no figure out?
it's not, so I don't know. But it's clearly a section of this map. They don't. Yeah, I don't know. I know nothing. As you can see, this map's really old. It's from September 2002.
So it's not the same.
So it might not be the same today, but I also have always made this connection. California was always very relaxed with their marijuana laws. So maybe they were all just stoned and didn't complain. That's always what has crossed my mind. I'm like, what's going on? But this section, this has very strong marijuana laws. So it's just a theory of mine. But anyway, moving on. So what's a map? I always took for granted you knew what a map was, but maybe it needs to be elaborated. A map is a snapshot of a particular area. Basically, a map is a picture of whatever area you're speaking of. So we could make a map of this classroom. We could make a map of the building. We could make a map of the town of Yorkshire. Could make a map of the entire school district or the entire county or the entire state or the entire world. A map is just the area you decide, or the person making the map decides to make a map of. And keep in mind that whatever's happening doesn't end just because the map ends. So this map of New York State, and this is common sense, but I just need to reiterate it. Here's a map of just New York State. Is this it? Is there more?
Yeah.
Yeah, okay, Canada is completely missing. Every other state in the country is missing from this map. Does that mean they don't exist? No, they still exist. Whoever made this map just decided not to include them. Because when you're making a map of New York State, you really don't care about Canada. They can't go there. Okay, can't go there. All right, everybody got these? All right, so then Keith already mentioned a contour map. These are contour lines. They are lines that connect areas of equal elevation. So they're still iso lines. They're just iso lines that connect equal elevation. And then a contour interval is the difference in elevation between two contour lines. I'm going to show you what they look like in a second, but it's what the lines are going up by. Everybody got these notes or not quite yet? I'm gonna show you an example of a mountain. Here's a picture of a mountain. This mountain is surrounded by the ocean. So what the people who made this map did, or who are going to make this map did, it'd be like if they went around to the mountain and painted a line everywhere where it was 0 feet above sea level. So they painted a line on the actual mountain. And then they went up to 500 feet above sea level. And they painted a line all around the entire mountain at 500 feet. And then 1,000 feet. And they actually painted this mountain with these lines. So now let me ask, what would this look like if somebody had a drone and were hovering over the tops of these mountains? If they were painted with these lines and they were hovering in a drone above them, what would the drone see? They would see the top of the mountain with the circle on it. Would they be able to see anything else? Now remember, they've got the lines painted on the mountain. This white mountain that has no other trees or trees or anything on it, just these painted lines. You were in a drone, wouldn't you see something like that? You would see each one of the lines. There's that line that was for 0 feet. Let's compare that to this. Look, there's that little triangle section. When we go here, there's that. Now, this was just what was going on the back of the mountain. I couldn't show you the same thing, but that's the 0 line. That was at the base of the mountain. Then there was the 500 line. So you'd be able to see these lines as you go up. I actually have kind of a good example of this. Here is, now I don't want you to look at me. I only want you to look at the screen because it's going to be deceiving a little bit. But if I just had that sitting here and you couldn't see in front of you, you could only see the screen. What do you see on the screen? Okay, in a second, what do you see on the screen? What? Help. All right, what do you see on the screen? You see lines, and then you see the colored line, or the colored section. So again, if I was to just trace these black lines, in fact, I'm gonna do it. And I know they won't be able to see it on the Zoom, but if I just trace these black lines, or a few of them at least. I'm going to turn off the screen for a second. Isn't that the map with a bunch of lines? Now I didn't label anything, but without the color, it's just a bunch of lines. Yes, stop saying no. Now, if I was to turn this, again, let me get rid of the lines I just spent 5 seconds drawing. So now you could see, okay, here, and I actually like it better. Yeah, I like it this way. So here is the 100 line, and then the 200 line, and the 300. When you go here, you can see, well, there's the 100 part of the mountain, then the 200, the 300, and all the way up. So these contour maps are a way of making a 3D shape flat. And we're going to learn how to do those maps. That's literally all we're doing for like the next week. Let's go back. Huh? Okay. All right. I think that's because we have about 10 minutes, right? Is that what the bell means?
Yeah.
Okay, that's where we're going to stop, and I'm going to hand back your test. I'll be honest, the test grades were not awesome. You may have already noticed into the grade book because I put them last period. So I'm going to hand them back, and I'm going to remind you, you can do test corrections. So test corrections. just like the last time, there's a worksheet that goes along with test corrections. You write the number of the question, your answer, the reason you missed the question, like if you screwed up latitude and longitude, or you screwed up north with west. Then you're gonna write the correct answer and why it's correct. You're going to turn this in, and then you have to retake a similar but different test. When you retake the test, I guarantee you 10 points higher. So if you got a 55, if you do the work and retake the test, you're guaranteed a 65. But what I've learned by doing this over the years is most people don't just get 10 points higher. You learn from your mistakes, because this is basically studying. So if you learn from your mistakes and you do awesome, I'll give you whatever grade you earned. So if you originally had a 55, by doing the work, you could at least get a 65, guaranteed 65 by doing the work. And you could get up to a 100 or an 80. And let me tell you, putting those higher grades into the grade book will change your average drastically, even if it's only the 10 points. Yeah.
You have a 99, you got a 99, you do your test correction, you get a 109.
No, I do only give a 100. So yes, it is not completely fair, I guess. But the 100, they could at least get the 100, but I don't give a grade higher than 100, but maybe I would. Maybe, I don't know. They would have to give me a good argument to do it. So in the next 10 minutes, we're gonna go over the test so that you can do test corrections if you need to.